We're delighted to have with us tonight our own Dr. Irminne Van Dyken. Irminne Van Dyken MD is a general and trauma surgeon who lives on Maui and works for the Hawaii Permanente Medical Group. Dr. Van Dyken is a fellow of the American College of Surgeons. She's also the first physician on Maui and the first surgeon in Hawaii to be board certified by the American College of Lifestyle Medicine. In her spare time, Dr. Van Dyken loves yoga, photography, sailing, cycling, and playing various musical instruments, including the guitar, ukulele, and violin. She shares her life with her husband, Russell, 16-year-old dog, Chaucer, 1-year-old puppy, Watson, and 2 cats. She has been a vegetarian since she was 9 years old and strictly plant-based since 2010. She is a board member of the Vegetarian Society of Hawaii and has a passion for sharing benefits of healthy plant-based living. Dr. Van Dyken's presentation tonight is entitled Improving Healthspan, Tools to Slow Down Aging. Join me in welcoming Dr. Irminne Van Dyken.
My name's Irminne Van Dyken. I'm a surgeon by trade. My true passion, though, and it's something I kind of found in a roundabout way, is helping people just like each and every one of you obtain optimum health by adopting a whole food, plant-based lifestyle. In helping all of you adopt optimum health, we have to talk about health span, and we have to talk about lifespan. Who's heard of health span? Anybody? Who's heard of lifespan? Okay, good. Let's play a what-if game. Would you rather? Show of hands, a vote. Would you rather live to the age of 65 years old? And if you're over 65 in this crowd tonight, that's great, you get bonus points, you can still vote. Would you rather live to the age of 65 and your whole life be in good health without any chronic disease, any disability, any illness? Or would you rather live to 120 years, but the last 30 years of your life are full of disability, chronic illness, possibly dementia? What would you prefer, 65 or 120? Okay, well, there's a third option, luckily. What if we could live to 100 years and possibly beyond without any of that chronic illness, without any of that disability, all the way up until shortly before or the moment of your death? Would you pick that? Yes. Yeah, I would pick that too. Well, ladies and gentlemen, I have good news for you. The results are in, the data has arrived. We now know that we can obtain a healthy lifespan, also known as a health span. We can live the majority of our lives free of chronic disease, free of disability, free of dementia, all the way up until the moment that we die. Would you believe it if I told you that a recent study showed that men, if you adopt a healthy lifestyle, 5 very simple lifestyle factors, men would live on average 12 years longer and women would live 14 years longer just by doing 5 simple things? Would you believe that? Well, it's true, so we're going to talk about it. So let's start with health span. What is health span? Health span is defined as this. Basically, it's the amount of your life that is spent in good health without any chronic disease. So tonight, we're going to talk about a few things. In order to talk about health span and lifespan, we have to talk about aging. Aging is important. So we're going to talk about aging, and we have to get into the nitty-gritty. I'm sorry if you guys don't like science, but I am a nerd. I love to geek out. So we're going to spend a little bit of time talking about the science, the mechanism behind aging, what happens. We can't talk about attacking those aging mechanisms unless we talk about how it happens. So we're going to talk about that. We're going to talk about what is aging, what is the mechanism, and how can we slow it down. That's everything in a nutshell. Of course, this is a Vegetarian Society lecture, so we're going to be talking a lot about food, but we're also going to be talking about some other strategies that are super important, as important, and possibly even more important than the food itself. All right, so aging, what is it? What do you guys think of when you hear the term aging? I'm super informal, shout out, what do you hear?
Disability.
Disability, okay. What else? Yeah, okay, okay. Do you think it's possible to age gracefully?
Yes.
Age in grace? Okay. I like this quote. Aging is an extraordinary process where you become the person you always should have been. That's by David Bowie. I love that quote. So, when we think about aging, we think about young versus old. What's the differences? What do you see up there? What makes a person age? Stress, yes, but physically, what are we seeing? Wrinkles, gray hair, drooping skin, creases, absolutely, yeah. What?
Telomere length.
Oh, you are jumping the gun. I love it. Telomere length. So yeah, so we see cosmetic things, but what we really want to know is what happens on a cellular level. What happens deep down in the little mechanism in each and every cell of our body? That's what we're going to be talking about. So let's talk about the global situation. We have a big world. We have a life expectancy that every year goes up and up and up, and that's a beautiful thing. We're living longer, right? But the thing is, chronic disease is also rising. So as we're living longer, we're also sicker. So there's about half of all adults that have one health condition, one chronic health condition. And then we have 1 in 4 adults that have 2 or more chronic health conditions. It's a serious thing. So we're gonna look at some of the data. This is a life expectancy curve, starting at 1851 all the way to projected to 2031. You can see that in 1851, you had a 50% chance of making it to 50 years old, right? 2031, you have a 50% chance of being 95, easy, right? That's the projected. Interesting. So what do we think changed between now and then? What changed? Industry, yeah. Medicines, antibiotics, huge, right? Vaccines, huge. Drugs, yeah, absolutely. I mean, modern medicine has really made our lives longer, right? But they've also allowed us to live with chronic disease longer, right? So let's look at this a couple other ways. In 1800, most people did not live past 40. That red is a low life expectancy worldwide. Fast forward, 1950, you can see, yes, the yellow is longer, 60 years, people are starting to live longer. And if you look even more, 2015, we're doing pretty good. We've got long life expectancies. Look at Scandinavia, Canada, they're all living a really long time. But what's striking about this graph is even today, there's a lot of inequality. Look at sub-Saharan Africa, low life expectancy compared to the modern Western world, right? Interesting. Did you know this? Women on average live longer than men? Why? Okay, that's a good one. Well, the truth is, they don't do this. They don't do this. Right? Women have a little more common sense. No, but in reality, the majority of the male life expectancy is because young males who get into accidents, etc., that is one of the reasons why women live longer. So lifespan versus health span, and we talked about this a little bit. Lifespan, right, is how long we live. Health span is how healthy are we? What is our health expectancy? That's what we're going to be focusing on today. The spans currently don't match. So when you look at this graph, you can see 1900 versus 1960 versus 2010. 1900 on the left, you have health span and lifespan right next to each other. They're almost the same. You go all the way to 2010, whoa. You've got a lifespan that's like this and a health span that's like this. 20%, the average person spends 20% at the end of their life with chronic disease, disability. Not a fun way to live. So let's think about this. How could we fix those numbers? What could we do to change that? Well, we could postpone aging. It might be more effective. It might be less expensive than treating these age-related diseases. Think about it. If we can postpone a chronic disease like diabetes that needs dialysis, if we can postpone that by 5 years, 10 years, that is huge. You with me? Yeah. So money-wise, heart disease, cancer, diabetes, those are the ones that take the majority of the funds at the end of our lives. So where do you stand? My question is, have you ever done any assessment of yourself to figure out where you might be in a longevity continuum on those curves? There are some calculators. They're not 100% based on science, right? It's not predictive. You are going to live to be 97 years old. No, it's not like that. 100% science, but it's a good indicator. I have a favorite, and it's made by the Blue Zones. It's called the True Vitality Test. Has anybody taken that? So if you go to Blue Zones and you look up True Vitality Test, it's a 3-minute test, and they give you a whole questionnaire about what do you smoke, do you not, are you active, are you not, this type of thing. And then at the end, they give you an estimated life expectancy. But the cool thing is they'll go past that and they'll say, you know what? You could increase your life statistically by 2 years, 3 years, 10 years, if you do X. If you have one more serving of vegetables every day. If and they kind of add on to it. So it's a nice starting point. So we got to put our science hats on, our nerd hats. We have to talk for a minute just about aging, the cellular aspects of aging. What happens and how can we slow it down? Over here, there are 9 separate hallmarks. This is a landmark paper that was published in Cell Magazine, 2013. Hallmarks of aging. All of these things we see in the cells, in our DNA as we age. Genomic instability, and we'll go through these important ones. The telomeres that we were talking about. We see telomere changes. We see epigenetic dislocations. We'll talk about that as well. Show of hands, who's heard of epigenetics? Good. Wow, we got a smart group. This is awesome. Okay. So when you break down the hallmarks of aging, you actually have 4 of them, which we call the primary hallmarks. That is the index. That's where everything seems to start. So once you have those 4, then you have the antagonist hallmarks and the integrative. These are ones that depend on those first 4 to start the cascade before you can actually proceed with aging. So let's look at those first 4 because, to me, they're the most important out of all of them. So first one, genomic instability. What does that sound like? Our genome is unstable, ready to topple over, essentially, yeah? Well, we get DNA damage throughout our lives. We can get DNA damage from things like UV light, right? Radiation, whether it's from an X-ray or from another source. We can get it from the foods we eat. We can get DNA damage that cascades down this entire cascade. We get genomic instability and our DNA cannot replicate in a usual way, okay? The other thing is we can get random DNA breaks. Every time our DNA divides, there is a chance that it cannot divide perfectly and we get a DNA break. And that is genomic instability as well. And those can get passed on throughout our lives. Telomere attrition is number 2. Telomeres, you guys heard of telomeres? Yeah, okay. So telomeres, our DNA is packaged into these beautiful X chromosomes. At the tip of our chromosomes, we have these things called telomeres, those golden tips, those caps there. These telomeres protect our genome, they protect our DNA. And what happens, if you want to think about it, it's kind of like a shoelace, where you have those little ends of the shoelace that are protecting the shoelace from fraying, right? And as we age, our telomeres can shorten. When our telomeres shorten, when they get super short, then our DNA divides and we get genomic instability. We get DNA damage. Make sense? Luckily, there's a lady named Elizabeth Blackburn, and she discovered the enzyme telomerase. She won a Nobel Prize for it. Telomerase actually is an enzyme that lengthens your telomeres. So we found out you can lengthen your telomeres. It's almost like reverse aging, right? You can do certain things to lengthen your telomeres. The third one, epigenetic alterations. So epigenetics, I saw your hands. I know you guys have heard of epigenetics. Epigenetics is super complicated, but also super, super fascinating. Epigenetics is what dictates whether our gene or from our DNA gets expressed or not, okay? So, complex picture, but I'm gonna simplify it for you. The things that this is up here for are the people who are nerds like me who wanna know how it happens. And what it is on this side over here, you have environmental stimuli, that's huge. Stimulus from the environment, or nutrient availability. Do you have nutrients from your diet, or are you starving? Has anybody heard of the hunger winter? The hunger winter. I'm Dutch, right? So this speaks true to me. My grandparents lived this. This is a winter that happened in the Netherlands, World War II. The Germans occupied the Netherlands. The Dutch people had nothing to eat. They were starving for over a year. Malnourished, they had no nutrients. And you want to know what they found? Scientists are finding from the hunger winter? They're finding that those children and grandchildren, me, have changes from what my grandparents went through in that winter, right? That's epigenetics. It gets passed on from generation to generation. So let's simplify it a little bit. The epigenetics is this box here, yeah? On the left, we have your DNA coming in, and then it goes through this box, and you have things, factors that can influence it. You have diet, diet can influence it. You have physical activity, you have microbiota. All these things can influence whether your DNA gets expressed or not. Every single cell in our body has the same DNA, but it depends on factors that we influence, that we do, like things we eat, etc., on whether those genes are expressed or not. How is it that the same exact cell that was a stem cell, one becomes a heart cell, one becomes a pancreas cell, one becomes a liver cell? How? That's epigenetics. What about bad genes, like the BRCA gene? You guys heard of the breast cancer gene, the BRCA gene? Epigenetics can turn that gene on or off. We're finding that there's certain factors in BRCA patients that can cause them to not have that gene be expressed. This is huge. This is the cutting edge of research right here. The last factor, the fourth factor, is loss of proteostasis. Basically, when our DNA gets expressed, it turns into protein. And the protein has to be nicely folded and packaged in these beautiful little packs. If it doesn't fold right, we have loss of proteostasis. We have a mess. Everything is everywhere, right? So if you look at it in picture form, you have the left is nice. Proteins are folding, everything's nice and orderly. The right, you can't find anything. Nothing is in order. You have no proteostasis. So those are the big mechanisms. Geek hats can come off now. But the good thing is we have mechanisms to attack each and every one of those. We have ways. Scientists are looking and researching different ways that we can stop these hallmarks of aging. So let's talk about some health span extension strategies, okay? Number one, what do you think the number one most important health span extension strategy is? Did I hear tobacco?
Smoking.
Number one killer in the world today, despite everything we know about it, is smoking. Smoking damages more DNA than anything else around. Tobacco kills over 6 million people worldwide every year. And there's a whole bunch of carcinogens, all sorts of bad stuff in there. And that goes for vaping too, by the way. Vaping is new, but we're learning. I'm sure you guys have seen in the news. It's really bad stuff. Okay, so here's this paper I told you about. The paper, the recent research that shows that males at 50 years, if they adopt all 5 of these lifestyle factors, can live 12 years. Females can live 14 years longer than the people that don't do these factors. Anybody want to take a stab at what these 5 factors are?
Exercise,
Yes, got one. What else?
vegetable intake,
Yes.
fruit,
So they lump diet into one, but yes, you're absolutely right.
sleep,
Surprisingly, sleep is not on there, and I think it's because we don't have enough research that is conglomerated yet, but I fully agree, sleep is huge when it comes to longevity and health span.
stress,
And that one too, that's another one that's not on there. So what's on there? What's that? Community, and that one too. Those are all the Blue Zones principles, right? That exercise is huge, yes. Exercise is definitely on there. So if we look, I know the graph's a little small back there, but if we look at females on the left, males on the right, you can see one factor, 0, 1, 2, 3, 4. If you adopt 5 factors, your life expectancy goes up big time. And the same is for men, okay? This is a huge study. They looked at over 100,000 people for this study. They followed them for 35 years. So how many factors? First one, not smoking, right? What about the next one? Oh, not overweight. And that ties into food, right? What are we eating? Are we overweight or not? 3, physically active. You want moderate or vigorous activity. 4, moderate alcohol intake. So when they say moderate for this study, 2 drinks a day for men, 1 for women, okay? And a high diet quality score. But their diet quality score was dictated by fruit and vegetable intake. How much fruit and vegetables are you taking in every single day? Simple enough, right? So if you guys all adopt this, 14 years for women, voila, extra life, right? Okay, so another graph just displaying the same thing. Even if you start later in your life, you can still reap the benefits of this. This is not something you have to do your entire life. You can definitely start later in your life. So if we address these hallmarks, if we work towards that, we can slow down aging. We know that. We can forestall disease, and we can delay death, longer health span, right? All right, so let's talk about strategies. There is one strategy that is famous, that is the best known for lifespan and health span extension. Overall strategy. Any guesses? Kind of, but it's actually much more fanatic than that. We're going to talk about when we eat, what we eat, and how we move. Those are the big things. But caloric restriction is number 1. Who's heard of caloric restriction? Okay. What do you guys know about caloric restriction? Is it good? Is it easy for people to do? Okay. Okay. So let's talk about it. Well, caloric restriction is defined as anywhere from 10 to 50% reduction in calories compared to people on the standard American diet, right? But there has to be no malnutrition, no starvation. So this is different from my grandparents in the Dutch hunger winter, right? They did not have this. This is no malnutrition. They're still getting enough nutrients, okay? And yeah, we've seen it in many different species, all the way from yeast to fruit flies to worms to rodents to primates. And humans, we're getting some preliminary data. The most famous caloric restriction experiment, Biosphere 2. Who's heard of that? Biosphere 2, yeah. So this is such an interesting thing. The guy who started this, Roy Walford, believed in caloric restriction. He wanted to study it. But this entire experiment was to see what the feasibility was of living on Mars in an isolated dome, right? So this took place in 1991. Middle of Arizona, scientists built this big, huge dome, 3 acres, and they encased everybody, 8 people in it, 4 men, 4 women, okay? These men and these women were gonna eat the food that they grew. They had a couple chickens, but I think that was it as far as meat. They sweet potatoes, they had fruits and vegetables. Unfortunately, they found out they were not the green thumbs they thought they were. They couldn't grow as much food as they needed, but they were cut off from the world. So they only took in a small amount of calories, traditional caloric restriction. So for 2 years, they were eating a nutrient-dense diet. It was sweet potatoes, like I said, it was vegetables, fruits, nuts, legumes. 2 years they lived that way. They came out and Roy Walford noticed that they had all lost weight. Okay, that's pretty expected if you're not eating as many calories, right? But they also found all of these other indexes looked better. Their cholesterol went down, their body mass index went down, their blood sugar went down, blood pressure went down. They even measured some markers consistent with premature aging, and those were down as well. And interestingly enough, Roy Walford said this: all crew members remained in excellent health. They sustained a high level of physical and mental activity throughout the entire 2 years. They were not laying around feeling crummy for 2 years. They actually did okay. But it took a toll. This is Roy Walford, the guy that did it. There he is on the left after 2 years of caloric restriction. Not much body fat left on him, is there? And then, a year after, he regained it all. I gotta say though, he doesn't look very happy on that one on the left, does he? It's gotta be pretty tough to deal with that. So, most humans will not undergo caloric restriction for a long time period. It's hard. And we center our culture and everything about us around eating, right? We love having meals, people over, that sort of thing. Caloric restriction is hard. So we're going to talk about some other options that might be a little more feasible for us. Oh, I'm sorry. I'm going to tell you first about one more study. This is from Duke University. They tried to recruit college kids to be going through a caloric restriction trial. So 145 volunteers they got. They wanted 25% calorie restriction over 2 years. Could you imagine as a college kid, 2 years being calorically restricted? Well, they got 12%, and that's actually pretty good. 12% caloric restriction over those 2 years. But even with 12%, they saw that there was a slowdown in biological aging, and all of those biomarkers went down. Just 12% caloric restriction. So it doesn't have to be extreme. It doesn't have to be 50%. It doesn't have to be. It can be much better. So let's forget the lab for a minute. Let's talk about real life examples. Is there any place in the world that we know of where there is caloric restriction that we can kind of look in at these people living? You guys will know it once I say it. Anybody know this island? Kind of similar to Hawaii, a little bit.
Okinawa.
Yeah. So Okinawa, Japan. There was a scientist, Mr. Kagawa, published his paper in 1978. He noticed that school children in Okinawa were actually eating 2/3 calories compared to the kids that were on the Japan mainland. And then he started looking at the adults. He found that they ate 20% fewer calories compared to mainland Japan. He also compared it to the standard American diet. They ate 40% less calories. And what did he find? They're like the longest living people in the world. And they have the longest health spans to boot. Quite interesting. So what do the Okinawans eat that are, that are healthy? Yeah, so if we look at a Blue Zones graph, 67% of what they eat is sweet potatoes. Okay, that's quite a bit. They eat some rice, some other veggies. They do have a tiny bit of fish in their diet, but it's very, very rare, maybe once a week. right? Mostly it's plant-based, whole food, no processed food. What do you think? Is it a hard sell, caloric restriction? I think it's a hard sell. All right, so other options. Anybody heard of intermittent fasting? It's all the rage. Anybody done it? How do you feel? Good, yeah. So many people report feeling good. The thing is, the intermittent fasting studies show that people that do that, they take in a little less calories, but it's about the time of day when they're eating it, okay? And it mimics caloric restriction. So there's different types, tons of types. What type did you do? 16-8, okay. So 16-8 is the time when you have an 8-hour eating window. That means 8 hours of the day you eat, 16 hours of the day you don't. Interesting, right? Then there's a 5-2. You fast 2 days a week, you eat 5 days a week. Then there's alternate day. There's so many different flavors of this. Alternate day, every other day you fast, right? There's cyclic fasting. Once every few months you fast water only 3 to 5 days, right? And then there's something called the fasting mimicking diet, where you take in about 600 calories a day for about 5 days. And it's recommended about every 12 weeks to kind of do a reset. And studies are showing even just this, not your whole life being calorically restricted, but even just this can improve your biomarkers, and especially your longevity markers. One study, again, just to illustrate the alternate day fasting, you have Monday, Wednesday, Friday, Sunday, you fast, and the next week, Tuesday, Thursday, Saturday, and you just keep alternating that. And this study, they did show improvement in many markers of health. But it's still, I would say, a hard sell. It's hard. And we're here to talk about food, right? I love food. I don't know about you guys. So are there any other options? We're going to talk about some. Anybody heard of methionine restriction? Methionine restriction. Methionine is an essential amino acid. It's one of the acids we need to live and build muscle, etc. However, we know that restricting it increases your lifespan. So, how does it do that? Via many different mechanisms, largely epigenetic. So, you take a look, complex molecular mimicry here, but it goes through an epigenetic change, and at the end, we get activation of stress-resistant genes, which means longer life. Methionine, what foods contain methionine, and how can we restrict that? That's an interesting question. Well, biggest forms of methionine are dairy, so whey, and meat. So turkey, chicken, beef, salmon, pork, cheddar cheese, eggs. All those are pretty high sources of methionine. If you are wholly plant-based, you're cutting all that out. You're still getting the methionine you need in your diet, but you're not getting the excess methionine, which equals more lifespan. Make sense? Okay. So theoretically, we look again. So methionine restriction equals decrease in animal protein, decrease in meat, which activates or decreases all these pathways. So mTOR and IGF-1 are two very famous molecular pathways that are associated with early aging, inflammation, cancer, etc. Those get shut down, increase longevity. So what about protein restriction in general? And let me pose this question. Does being whole food plant-based result in a caloric restriction that could be enough to result in increased lifespan? You don't think so? What's that? Yes, you definitely need protein restriction, but by nature, being whole food plant-based, you're not getting a lot of those large amounts of protein. But you are right. So protein restriction, this is the big thing, right? We live with it even if we tell people that we're vegan. Oh, well, how do you get your protein? How are you gonna get your protein? Oh my gosh. Think about if we telling people that we're protein restricting, right? I'm vegan and I protein restrict. That's gonna really really change some thoughts here. But let's briefly talk about protein requirements. This is from the USDA. They want us to eat 10 to 15% of our protein, right? That's 0.8 grams per kilogram per day. So for women, 46 grams, for men, 56 grams. Okay, not too bad. There are some important exceptions. If you are pregnant, if you are breastfeeding, if you are a child growing, if you are an elderly person over the age of 65, you do not want to protein restrict because you are already losing muscle mass so fast. Makes sense?
It says athletes.
And athletes, thank you. And that's athletes if you want to build muscle mass. You don't really want to protein restrict, okay? The average human, American, consumes 2 times the recommended daily allowance of protein. We are all, as Americans, eating way too much protein. High protein intake can result in all of these things. So it can be hard on your kidneys, it can worsen diabetes, and it can shorten your lifespan. When I say the average American consumes 2 times the RDA of protein, over 80% of that is animal protein. So largely, it's animal protein. Could the USDA be wrong? And I only bring this up because there's a Dietary Guidelines Advisory Committee 2 years ago that actually sat around a big table and they were giving recommendations to the USDA. They said, you know what? I think that we should minimize meat intake. I think that we should shift more to plant-based foods because there is an overwhelming body of evidence that says it's better for your health. The USDA said no. Why?
Because they're tied to the animal.
Thank you. You have to think about where they're getting their money, the lobbyists, the support they get, the subsidies. They are funded by meat and dairy. They are not going to be accepting any recommendations like that anytime soon, unfortunately. So, dietary protein, longevity, metabolic health. Back to some more science. We know reduced protein intake, so low protein or high carb, right? A high carb, low protein diet can play a critical role in our overall health. So therefore, this paper says, a low animal protein diet, particularly a diet low in red meat, will provide health benefits. And in picture form again, so we have low protein diet here, low protein, high carb diet. That means less amino acids. So these are leucine and arginine are amino acids. You have less of those, you decrease this mTOR pathway, which is one of those aging pathways, and it results in longevity. So that's the whole thought of how it works. On to a new strategy. Hypernutrition with specialized foods. Let's talk about foods for a minute. Are there foods that we call epigenetic modulators that can turn on the healthy aging pathways and turn off the unhealthy aging pathways? What do you guys think? Yes, no? There is, for sure. And it's a whole new field of science called nutrigenomics. So we're talking epigenetics, nutrigenomics. Nutrigenomics is closely tied, but basically the definition is there. It's the scientific study of the interaction between nutrition and genes. Scientists are realizing this. Your nutrition can affect your genetic expression. So back to this picture, right? Our diet, the microbiota, exercise can affect how our genes are expressed. So yeah, recently there was a paper published talking about anti-aging effects of bioactive molecules isolated from plants and fungi. So busy picture, right? We're isolating molecules that delay aging. Look at all these little molecules. See what they have in common if you're a chemist? They're like little rings. Do you guys see that? They're all kind of similar structures. Well, let me just break it down. These are the foods, and we'll kind of touch base on some of these. I'm going to zoom in here. So when we look at the top, there is a drug called metformin. Have you guys heard of metformin? So metformin is actually isolated from the French lilac plant, okay? It is a plant compound that scientists found, and we actually give it to people who have diabetes. It lowers their blood sugar. But scientists also found that patients that have diabetes who take metformin live longer than patients who have diabetes who don't take metformin. And we're finding in animal studies as well, metformin seems to trigger that pathway. Now, is that a reason to take metformin? No. We don't know enough about it, but it's a very interesting molecule, and it comes from a plant. Then we have rapamycin, which is also a similar thing. So rapamycin is a compound which is created by a bacteria that a scientist found, this is a true story, scientists found under one of those big heads in Rapa Nui, right, on Easter Island. You know those big heads? He found a bacteria under there that created this compound. And he thought it was going to be an antibiotic. That sounds like an antibiotic, right? Rapamycin. But it's actually a compound that in animals, for sure, will extend lifespan 30 to 40%. And in humans, doesn't look so promising, so don't take that one either. But when we look at food compounds, you can see there's a whole array of things. My favorite herb on the list, curcumin, right, from turmeric, also has been shown to accelerate health and slow down aging. Now, we have all these different ones as well. So aspalathin is from Rooibos Tea. Have any of you guys had Rooibos Tea? Rooibos Tea. It's from South Africa. It's delicious. Yeah, there's no caffeine in it, but it's been shown to slow down aging. And then we have other things like berberine. Berberine is a compound. I don't know if you've heard of it. It comes from the barberry, not the burberry. It's kind of confusing, but berberine. And then we have capsaicin from hot chili peppers. EGCG from green tea is also a common player. Genistein we find in soy. Allicin in garlic. Butene is in beans. Celestrol is in avocado. Fisetin, strawberries. Right? So we know these compounds are things that are being researched and isolating. The scientists are isolating compounds from these to slow down aging. If we look at the other part of the graph, this one from lilikoi, right? Passion fruit, there's a compound that they're finding. These pills I put up there because there's no food equivalent. These are compounds that scientists have synthesized and they're studying and trying to figure out how it slows down aging. We have garcinol from mangosteen, from the rind of the mangosteen. We have celery, epigenin, and we have these other ones. Huperzine A is a fir moss, which they have found a compound from. Acetic acid in vinegar. This one, naringin, is from the bitter peel of a grapefruit. So these are all interesting compounds that we are researching to try to find out how to extend life. Curcumin, again, as I said, one of my favorites. We honestly should be having turmeric or curcumin every day in some form or another. It's anti-inflammatory, it's anti-aging, it's anti-cancer. Gotta get your turmeric in. Okay, one more term for you all. Have you heard of hormetic effects? Anybody? No, new term. Okay, so hormetic effects. This is a really good one. So hormesis. It's described as a biphasic dose response to environmental agents. So something happens in your environment and you respond either very well or not. And it's dependent on your dose. So a low dose means you have a good response. High dose means you could have a toxic response. This is very, very important, and this is the reason why I do not recommend we take supplements or concentrated compounds. So if we look at a hormetic effect, let's take exercise, for example, right? If you look here, the stress amount, if you have a low stress exercise, you're not really gonna get that good of results, right? If you have a moderate, you're gonna get really good results. But if you have a high intensity, it can actually be detrimental. If you exercise too much, it can be detrimental, right? If we look at nutrition, it's the same thing, your nutrient concentration. So if you have a low, you're not getting enough, you're a deficiency, that's a problem. You're not gonna get a benefit. If you have an optimal concentration, that's good. You're gonna get the best effect. But if you have too much, say from a supplement, you could have toxicity and have a bad effect. So that would be a good reason why we don't want to supplement with things like vitamin E, right? People thought vitamin E was the holy grail. It was gonna cure cancer, all this stuff. And then we did long-term studies of people that had taken vitamin E every day and they had a shorter lifespan and more cancer. But if you get vitamin E from your foods, it still sticks with the principle of lower cancer rates, antioxidant, etc. Does that make sense? Okay, good. Back to telomeres, very, very quick. So we talked about the telomeres, the shortening of the telomeres, the telomerase, which can lengthen the telomeres. This is a study where they looked at dietary patterns and telomere length, and it's a recent study. And what they found, out of every single food that they studied, only fruits and vegetables were the ones that had increased telomere length. Not grains, not donuts, not meat, not any sort of processed foods, only vegetables and fruits. Interesting, right? Last wildcard, and one of my favorite topics to talk about is the microbiome. Microbiome, who's heard of it? You guys? Yeah, okay. So for every one cell that we have, there are 10 cells that are on, in, and around us that are not human. They are bacteria, fungi, viruses that live on us, in us. They create compounds. They metabolize a lot of the food that we eat, but the compounds and the hormones they make dictate our health. They've been linked to serotonin levels, depression if you have a poor microbiome. They've been linked to all sorts of things, and they're crucial in our immune system, and also, we're finding out, our longevity. So the microbiome, as we talked about, here's our GI tract where most of these microbes live. Anybody seen a picture of a colonoscopy? The inside of a colon? When you look at a colon, it looks like this. Nice, smooth lining. But when you zoom in under a microscope, the smooth lining is like shag carpet. It's like all these villi that go up and in and out, right? Here's a picture of the villi. Clean, this is sterilized, okay? Here's another picture, clean, sterilized. Imagine, not clean. This is all the crypts, every little fold, you have bacteria, viruses, fungi living in there. Eating the food we eat, digesting the food we eat, creating hormones, creating chemicals that dictate our overall health. Our microbiome is crucial to our overall health. We know that as we age, our microbiome gets less diverse. Diversity is a good thing. We want many different kinds of microbes in our microbiome. As we age, the ratio changes. We get more of the unhealthy bacteria and less of the healthy, as opposed to the young ones who have very good, healthy bacteria. How can we optimize our microbiome? Well, I'll refer you to the VSH YouTube channel where we have a couple really good lectures on the microbiome, so you can learn all about it there. But what it comes down to is what you feed the bacteria and the organisms in your gut. Prebiotics, which are foods, high fiber foods, we need to take those in. We need to take in probiotics, live bacteria. You can get it from food, kimchi, right? That's a great source of probiotics. And symbiotics. You can get symbiotics these days, which are a combination of pre and postbiotics, right? But the best way to keep a healthy microbiome is by watching what you eat. Eating the foods that will nurture your bacteria rather than starve them. So we got to talk about exercise, the last piece of the puzzle. Exercise is huge. Regular exercise has multi-system anti-aging effects. It's one of those things that is almost, if not as important as our diet and what we eat as we age. So this paper published, exercise attenuates the major hallmarks of aging. Exercise can lower those 9 hallmarks that I showed you, can slow those down. But the paper also said only 10% of those 65 or older exercise. That's a pretty low ratio. And exercise is different for every person. Exercise is enough to get your heart rate up, get you moving, right? It doesn't have to be something strenuous, it doesn't have to be running a marathon. It's whatever for you individually will get your heart rate up, okay? So when we look at the cellular hallmarks of aging, all those 9 things we talked about, you can see exercise, and I know the text is small, but it's to prove a point. Exercise can modulate all those different hallmarks. And also, it improves your brain function, your heart function, your muscle function. You have much more muscle mass. You have less frailty as you age. It increases your physical fitness. So exercise is critical. So when we look at exercise with the elderly, they say, okay, well, running 4 to 5 miles a week reduces your risk of death by 45%. That's a pretty big number, 45%, by the way. But 4 to 5 miles a week, that's a tall order, especially in a lot of people that are elderly. But if you break it down, it's less than 15 minutes of vigorous exercise a day. Not too much, right? 15 minutes, fairly doable. What about exercise type? Any idea what type of exercise is the best when it comes to aging? Aerobic, I heard walking, I heard swimming, yeah. What? Weight-bearing exercise is good, absolutely. But the one exercise that scientists are finding actually manipulate the aging markers the most is something called HIIT. Have you heard of that? High intensity interval training. That appears to be the best. So this is a short segment of time, 3 to 5 minutes, doing something as vigorously as you possibly can, getting your heart rate up, stopping. That's HIIT. Talk about an easy workout. 4 or 5 minutes, right? And then you're done. That's great. But this is the key point. You have to have a high heart rate and a high respiratory rate. That's the key to the entire thing. So vigorous activity, how do we define vigorous activity? Sweat, okay. What else? Should feel challenging. If you're exercising with your friend, you shouldn't be able to have a conversation. You should be so short of breath that you can't talk, right? That's vigorous exercise. And the VO2 max is a measure of fitness. You want to be 70%, give or take, of your VO2 max, and about 80% of your maximum heart rate. That's vigorous activity. And it's different for everybody. For one person, it may be vigorous activity walking from the bedroom to the kitchen and back. Maybe. And that's okay. That's activity, right? So again, complex picture. Exercise affects all these different pathways, which ultimately leads to downregulation of our aging pathways and longevity. Same study, life expectancy. When we're looking at humans, you can see we have much more life expectancy the more we exercise, even starting in old age. So it's never too late to start. Couple more things, and then we will be on our way. Thermal stress. Anybody heard of thermal stress when it comes to aging? No? Cold happens to be really hot right now. Have you guys heard of cryogenics, ice baths, ice water plunges, anything like that? Yeah, I know. And it's more interesting than anything, right? So many animals have been shown to live longer at lower temperatures. Insects, fish. We haven't put a human in ice water for years, but the humans are starting. And they think it's because we have something called brown fat. Have you heard of brown fat? Brown fat is something that is in the back. You can see the red on this guy's PET scan. That red is brown fat. The thing with brown fat is it's metabolically active. It burns calories. It also keeps you warm. Brown fat, we have most brown fat in our lifetime when we are young, when we are infants, when we are young children, and we tend to lose it when we get older. But scientists have found that cold plunges, ice therapy, cryogenics increases your brown fat. The interesting thing is brown fat also seems to enhance longevity. It downplays those aging pathways. So, if cold works, what about heat? I prefer heat. Some like it hot. I live in Hawaii, right? Well, they've studied saunas. And actually the Finnish, who invented the Finnish sauna, have the most data on it. There's a guy called Dr. Laukkanen, and he's from Finland, and he spent his entire career studying sauna and health effects. And he's found some very interesting things. But the Finnish sauna is different from your average sauna. It's pretty specific. So you want to have it dry. They do have a heater where you dump some water on every now and then, so it is slightly humid, but it's not a wet sauna. And temperature-wise, 80 to 100 degrees Celsius, and time-wise, 5 to 20 minutes a week, or a day, 2 to 3 days a week. So these are the conditions set forth in the study. And what they found, well, if you sauna bathe, you actually have less cardiovascular fatal events. And your all-cause mortality, meaning your death from anything, goes down the more that you go in a sauna. So if you look at the curve, you have sauna frequency per week and your risk of dying. Simple, right? And you can see that the sauna bathing is associated with lower death risk. Similarly, the duration per session. So the longer that you are in the sauna, the more lower your risk of dying from any cause. So that's interesting. When we talk about longevity, wrapping it all up, longevity is this thing. We wish there was just a clear pathway where we could go and figure out what's the best way to live a long, healthy life, what's the best way to have a health span that is appropriate for us. There's choices we make, right? We can choose exercise, intermittent fasting, phytochemicals, and we can activate and downregulate appropriate pathways and live forever, or we can be sedentary, we can overeat, we can eat sugar, we can eat high protein, and again, activate the mTOR, which is one of the bad pathways, and have a lower lifespan. It's our choice, right? We know we're empowered with this information and we can hopefully make appropriate choices. So while we think that the road is straight and there is no turns and it's an easy decision and this is what we have to do, we all know that life is super complicated. We're full of turns, twists, everything, every which way. But we can, whenever we can, make the best choices for us as far as our health and our overall lifespan. So it's our life, it's our choice. We can do what we want with it. We can choose to be calorically restricted like Roy Walford for 2 years, or we can choose something in the middle, something a little different, maybe some methionine restriction, maybe whole food plant-based, maybe intermittent fasting. You can try to adopt some of those in hopes of having more longevity. So you can age fast, you can age slow. It's entirely up to you, up to the choices that you make. So thank you guys so much for your attention tonight. If you want to follow, we are on YouTube, Instagram. We like to do little health videos, about 5 minutes or so, just to talk about a certain topic and hopefully educate some people. So thanks again. I will take any questions. That is a great question. So the question was 2 drinks of alcohol per day. Mentioned in that study, is that a mandatory thing? Should we be drinking alcohol or not? And no, it's a cutoff for excessive drinking, so not drinking more than that. There's actually a recent study that was published showing that there's no safe level of alcohol for our bodies. There's no safe amount. So yeah, I wouldn't say, yes, I need to have 2 drinks every day. No, definitely not. Good question. So the question is, when you say sauna, does it have to be infrared? These studies were not done on infrared saunas. They were done on Finnish saunas. So that is a heating element in the center of a cedar sauna with some water dumped on it to make a little bit of humidity, but not too much. It's not infrared. There are some studies with infrared and near infrared saunas, but the data is not as strong as the Finnish sauna, surprisingly. And I think it's because the infrared saunas don't get as hot. They don't get quite as hot as how these studies were done. Oh man, that's a can of worms. Thank you for that. The question was, how important is it to optimize hormone levels as we age? That's a great question. And honestly, I don't know that anybody has the right answer for the optimization that's perfect. And it's really tough, especially for women going through menopause and having to deal with the hormone changes that happen. It's very tough, and there is a school of thought coming out that, you know, maybe we should try to supplement with bioestrogens, et cetera, as we are going through and for a few years past menopause. They feel that it's important to health. However, national guidelines all recommend no hormone replacement therapy because there's this data linking it with breast cancer. But it's a very, very complex problem, and I don't think we have a good answer yet. We haven't studied or found the optimum levels. Thank you, good question. So the question was, you mentioned taking vitamin E is bad. What about iron pills, B12, et cetera? If you are whole food plant-based, actually, if you are a human being, you probably should take B12. And the reason why is that our food supply is just so deplete of B12. So even omnivores, and actually omnivores, because vegans are pretty astute to this, omnivores have higher rates of B12 deficiency than plant-based people do, because plant-based people tend to supplement and the omnivores think they're getting it from food, right? Iron, it's a good idea to check your levels, and if you're anemic, you can try to get it from whole foods. So leafy greens is a good source of iron, etc. There are some people who have to supplement. That's okay with the iron. You want to make sure it's non-heme iron as opposed to heme iron. So heme iron would be from an animal source, non-heme from a plant source. Heme, H-E-M-E, heme iron. And the other big supplement that we should talk about since we're on this topic is vitamin D. So vitamin D is a huge thing. The problem is we don't know whether we're depleted or not, so we have to check. You need to get your vitamin D levels checked. If you are low, yes, it makes sense to supplement and recheck. If you are normal, then no need. Steam sauna, the question was what about steam sauna? I don't know, there's not as much data on it. You would think that it would be beneficial as well, because the sauna is healthy because it activates what's called heat shock proteins that help with your health. So a steam sauna would also give that activation, but all the studies were done on the Finnish sauna, so I can't comment. I can't extrapolate to a steam, I don't know. Yeah, so the question, or the statement question was, I believe that as we age, our absorption of nutrients goes down. I agree with that, and I think it's largely due to things like our microbiome that may not be as diverse and not absorbing the nutrients. There is definitely a change in nutrient absorption as we age, for sure. Calcium for osteoporosis, yeah, that's another tough one. The calcium, if you've been diagnosed with osteoporosis, you should be doing some sort of replacement. It doesn't have to be calcium supplementation. There's other things on the market, other medications that can help, not just calcium replacement. If you do not have osteoporosis, you can be eating your leafy greens. Some citrus on your leafy greens can help absorb the calcium better. That's a good way to go. Yeah. Thank you.
So everyone, mahalo for coming and have a safe return home. Good night, everyone.